Then I will share my screen. Okay, so let's start at the very first slide. So this is the virtual lab intro. It is based on AI for You experiments. My name is Martin Welz. I work for Fraunhofer in Germany, and I'm mainly involved in AI for You and also AI for You experiments. Okay, here is a brief overview of our agenda. So I will give a short introduction into Akumas and the interactive pipeline editor, so you can see how it can be done, how it is meant to work. Then we will talk about the container specification for reusable AI building blocks. I will give a few more pipeline examples, then possible use cases for research and education. And then we have testimonials from AI for You researchers. I'm very happy that they participate today and share the experiences with us. And then we will have some time for question and answers. Okay, so here is a picture of the AI for experiments catalog with the components already listed, but I will switch now to the live demonstration. So this is our production system, and here you see also the catalog. And I will go now into the design studio, Aku Compose, where we can visually compose pipelines. And we want to use a video pipeline for this example. And we will start, of course, with a data source. In this case, it's a video file broker. And the next step is then, I think it's the video segmentation is the next component in our pipeline. And you see that the components, the nodes, they have handles, and those are the connection points. And we see here, get video file job. This is the method that is the connection between the video file broker and the segmentation. And you see the other handle flashing, so it can be connected. So the editor helps you to connect the right ports together, which have the same method signature. So the visual editor is aware of the interface definitions and can therefore match the interfaces together. Okay, then the next node in our pipeline is video object recognition. And let's see, set config, no, get next video segment. That would be the right method to connect. Here we can connect it together. So what we have now is our basic pipeline together. And what we also can do is to add infrastructure nodes. So for example, to exchange the video files and segments, we would need a shared directory, for example. So we will use the persistent volume provider, and we can name it like data video incoming. So this is the path that will be visible to all of our nodes, and now we can connect them together. So each node, I need to help a little with the layout. Each node needs access to the shared directory. So all of them can connect. Okay. Then we have also maybe we want to initialize our models before the pipeline execution starts. So this is what we use here, model initialization. So we don't need to initialize the video file broker, only segmentation and the object recognition. And then as the last step, we might want to have some insight and diagnostic information for video object recognition. So we would use our TensorBoard connector. And would connect it to our video object recognition. Okay, so this is basically a short overview how a pipeline can quickly be assembled in the visual editor. And we have in the top row, we have the actual pipeline nodes. And we have in the lower row, we have I call it the infrastructure nodes or utility nodes. For example, we connected a TensorBoard to video object recognition to have a look into the model, into the insights of the model. We have a model initialization for our two video segmentation and the object recognition nodes. And we connected all of our nodes with a shared directory to exchange the big video files. So it doesn't make sense to transport the video files, the binary files via gRPC or some other communication directly. So we use this shared directory. Okay, so this was an overview of how pipeline composition can be done. And the next step would be then to validate it and deploy it into an execution environment. We'll switch back to my presentation. Okay, so we made this. It is also, the video pipeline is also available as a YouTube tutorial on the AI for You YouTube channel. And the Akumas architecture is like this. So Akumas is the underlying open source project that we use for AI for You experiments. It's a project hosted by the Linux Foundation under the Apache license, and we are running our own instance of it. So it is a clean microservice architecture running in a Kubernetes cluster. And it is very important to know that Akumas itself is the catalog and the visual composition and the database for all the model information, but is not an execution environment. So we need a Kubernetes execution environment where the pipeline can be deployed. This can be a local Kubernetes, or if you have it in your IT somewhere, you can then use this. Or in the course of AI for You, we will also provide in the summer of this year a small playground where at a small scale demo pipelines and trials can be run. Okay, so this is important to know because the deployment will create the Kubernetes artifacts that are needed for the deployment in the Kubernetes cluster. And there can be several components or means of execution. So we are working currently on a serial orchestrator, on a generic serial orchestrator that can orchestrate a pipeline. But there are different orchestrators possible. So we can also imagine a parallel orchestrator or a stream orchestrator that is more efficient, for example, because Akumas is quite a clean Kubernetes microservice architecture. It is easy to add simply more deployment clients. We have now the Kubernetes deployer. There might also be a specific deployer for HPC environments, like here in the HPC client. It might also be possible for other environments, maybe satellite image processing. This can be done, And it is a very clean architecture. Also, like the orchestrator, there can be different orchestrators for different needs. So the possibilities and the extension mechanisms are very interesting in this Akumas architecture. Okay, so how do we achieve all this to have this interoperability? At the very core of this, we have the container specification, which describes what we expect from a container and what makes them interoperable. So it is all based on free and open source technologies. There are no license fees or anything else involved. And it is based on Docker containers. So it is language and tool agnostic. You can, as a tool provider, you can put anything in there what fits into a Docker container. But the public interface needs to be described as a protobuf definition. So the service methods that a model offers to the rest of the pipeline needs to be defined as a protobuf definition. It's a simple and clear interface specification, which looks very much like simple Java or C code. And the communication is based on gRPC, which was invented by Google some years ago. And it is efficient and standardized communication. And what is very important is that there are code generators available for many programming languages. And all this makes it possible to automatically generate the needed communication artifacts so that we can dynamically generate all the necessary stubs and skeletons for the orchestrator, for example, to execute pipelines the orchestrator has never seen before. So that's possible. And I also put here the specification link. So we have this in our AI4EU repository if you want to have a closer look. So here's an example of the protobuf specification. You see it's the classical iris classifier example. So we define the input and output data structures, and then the service method, which is here the classify method, which takes an iris data frame as input and returns a classifier out as output. And what we also defined are the ports. We defined fixed ports where we expect the container to expose this interface, and we also specified a port for an optional web UI if you want to interact with the model during pipeline execution and have a look into it. That's also possible. So on these fixed ports will then be mapped onto Kubernetes services, and this will be transported to the orchestrator that it can know how to connect to the different models. Okay, so here are some more pipeline examples. Here's the audio pipeline. We have also the audio file broker at the beginning, and we have a dialog creator at the end. And what you see here is the level of granularity. So what we want to have are reusable components, and then we need to find a way to best encapsulate the functionality in a way that it can be reused. So we have the segmentation, we have audio speech to text for German, and we can imagine to have also the same model just for English or for Italian or for French. So we can easily switch out some nodes in this pipeline to fit different needs. And also we can add more functionality. So in this pipeline we have speaker recognition and also topic extraction. But maybe we don't need topic extraction, so we can make a smaller pipeline, and the same for punctuation and speaker recognition. Those are all optional nodes that can be quickly configured into a pipeline, then it can be deployed and executed. And this is possible also for people that are not experts for the machine learning internals of those models. They need to know their domain, how to work with audio pipelines and streaming all this, but it's not necessary to know about neural networks or other deep technologies used inside the models. Okay, so training is also possible. It's just a matter of how to configure and what methods are exposed by the node. So it needs to be, so the news trainer needs to be a specific node for this training pipelines. It knows how to parameterize the learning algorithm. So the training configuration can look like this. So this is inspired by the Keras model fit method. It has a lot of similar parameters. And the news trainer will feed this configuration into the classifier that should be trained. And the classifier then has several methods defined, like the classify method, which is used in the application case. So this is the application method, and this is the training method, train model. And we have set configuration, which is necessary for connecting the infrastructure nodes. And of course, in this case, if we do training, we want to have further insight into our model, and we connected also a TensorBoard connector. Then we can also have a Jupyter Connect pipeline, which can be automatically generated because of the properties of gRPC. So we can say, deploy me this model as a Jupyter Connect pipeline, which will then automatically look like this. We have a Jupyter node, Jupyter Lab node connected to the news classifier. And this Jupyter node can be automatically generated thanks to protobuf and gRPC tools and automatic generation, code generation. It can be achieved by a one-click deployment, and then in the resulting notebook, the connection to the model is already established, and you can directly interact in Python code with your model. And of course, you can use all the standard tools like Matplotlib, Pandas, or NumPy to print diagrams and do explorative analysis of this node. Okay, then we have possible use cases for research. It is possible to quickly configure and deploy training pipelines. We can imagine hybrid AI pipelines that combine symbolic and sub-symbolic tools or approaches. We can imagine to have reproducibility of pipeline runs when we automatically save and sign all parameters, for example. We can imagine reusable building blocks for explainable or verifiable AI. There is a toolkit from IBM, I think it's AI 360. This could be a possibility to include some of those nodes into the virtual lab. And of course, it is also possible to imagine, it is not yet implemented, but it can be done to do AutoML by reconfiguring the topology automatically after each run. So that there will be a node at the end of the pipeline that evaluates the training results, and based on this changes the topology and the learning parameters for the following run, and the orchestrator can this take into account and then execute the pipeline with the new hyperparameters and maybe differently connected. So the nodes need to be the same, but they can be differently connected. Okay, then we have possible use cases also for education. We can imagine live classes and exercises with Jupyter Connect. It is possible to implement parts of a pipeline, a specific node, for example, as part of an exercise. It also can be then executed and checked if it's really working. And can also be it can be used to explain AI concepts using those pipelines, or also then different scenarios. Okay, so this was the first part on the virtual lab functionality and possible use cases. And we come now to the testimonials. So the first one is Peter Schüller from TU Wien. And so I give now the word to Peter, and I will present the slides.
Thank you, Martin. You can go to the next slide, I think, yeah. So from my point of view, the vision of this AI for You experiment is that we make our assets that we have more useful, usable, and used. I did not invent this. This is from Alessandro, I think, that we have this as a goal. So we have useful assets. We all have that. But we also, so that others can use them and that they get spread in the world, we need to make them usable and they need to get used. So to make them usable, maybe they are difficult to set up. So we can use Akumas for that. We put it into a Docker container, and then it is much more easy to use Akumas to combine it also with other assets. And we also need to create something around of our assets to demonstrate them, to give a demo. And this is also where Akumas forces us to do this, more or less, because just a building block on this canvas of the Aku Design Studio does not do much. We need to have some kind of interaction. And then they can become used, the assets. Now you can go to the next slide. So I'm leading the task 7.8 in AI for You. This task is about encouraging everyone to create such Akumas pipelines. We have two types of Akumas pipelines. Actually, we don't call them pipelines anymore because we found out that we will need topologies. So we call them experiments and hello worlds. The experiments are created by each of the focus groups in AI for You: variable, verifiable, explainable, physical, collaborative, and integrative AI. And each of them contributes at least one experiment. And this is based on an existing research asset with the interfaces and a use case around. And the idea is that everyone with access to Kubernetes, maybe a local Kubernetes, a Minikube, can run this. And then there are the proof of concepts, small hello world examples. The target group are developers of AI for You experiments. Everyone who wants to start developing for this Akumas infrastructure. The idea is that they are simple enough to be taken as a template. And the first runnable hello world is the Sudoku Design Assistant. It is on GitHub. You can go to the next slide. This is just two screenshots of the user interface. I made this. It's a web interface. It is very ugly because I'm not good at web interfaces, but it shows that it works. So on the left side, you see you can click and select some numbers. On the right hand side, you see there's a partial solution to the Sudoku where this one green square is fixed to the number 6. And there are some fields that are not known and some fields are known. We just send this to an answer set solver and take the first 10 results. And then we show what are the same what are the equal numbers, and show this as a partial solution. And then the user can interactively continue to build the Sudoku. And if there is a conflict, the solver also shows which fields are involved in the conflict. This is a tiny bit of explainability demonstration so that the user can fix the Sudoku. Now you can go to the next slide. And how does this Sudoku example look like? There are three components. At the top, there's the web user interface, in the middle is the design evaluator, and below is the ASP solver. The only generic component is the ASP solver. The other components are here in the middle. There is the logic to transform the Sudoku into an ASP program and the ASP answer set into an explanation of what's happening in the Sudoku. And the web GUI just takes the user clicks and sends it to the design evaluator and displays the result. And so here we had to implement 5 services. All the field squares, rounded squares are services. And this way we get also a linear pipeline somehow. From top left, we go down, evaluation request, the job preparer, ASP solver, and then we go up again to display it in the user interface. Now you can go to the next slide. And this is how it looks in the Aku Compose Design Studio. Here we see we have cycles. Because we have 3 components, 3 Docker containers, and from the top, we have 2 connections to the next one down. One connection goes downwards and one goes upwards. That's why they are painted in such a strange way. And yeah, so we are currently working on making this deployable and also orchestratable in Akumas. And I think, was this already the last slide?
Yes.
Yes, okay. And that's it from my side. Thank you. And I'm working on deactivating this automatic layouting because it is very annoying also for me.
Okay, I'm glad to hear this. Okay, thank you very much, Peter.
You're welcome.
So the next one is Salvo, also from AI4U. So Salvo, I give you the floor.
Yeah, thanks. So let me just present you our experience from realizing the preparation of the components to be published within Akumas about explainable AI methods. If you go to the next slide, yeah, so this is basically the general approach that we are trying to follow. So having any type of, let's say, classifier at the moment, we are focusing on tabular data just for starting. The objective is to have a component that is able to explain which is the outcome of any classifier accordingly to a specific record instance that is arriving. Within AI4AU in the WP7, we developed a library of several explanation methods. Many of these are model agnostic. Let's say they do not make any assumption on the model that is used. So they are let's say, a natural candidate to be transformed into a component. I'm going to present you also the point of view of me and many of the researchers in the work package that has never been working on this kind of technology. So just to give you an idea of how much effort it may be necessary to get familiar with this particular kind of approach. If you go to the next slide, we started, let's say, from having all this library of methods implemented into Python, and by using, let's say, in this case, you can see a UPython notebook, a sort of self-explained notebook to show how to use the library. So what does it mean to transform this particular implementation into an Akumas component? Well, let's say the main limitation of this kind of representation is that probably for experts, for computer science people, it's something that is quite familiar, but for, let's say, a general public may not be so useful directly. Also, in particular instances, there may be problem caused by incompatible libraries. Let's say, just think for image classification and the conflict of resolution among, let's say, TensorFlow version 2 and version 1. Okay, so we started working on packaging our different methods within a component. So we starting from the initial implementation, so we had clear which is the signature of all the function. Next slide. We started by implementing these protobuf interfaces. Again, probably this one of the step that was a little bit more delicate because we need to get familiarity with the tool, with the language. Of course, there is a little bit of change of perspective on how you define things in this particular kind of language. But at the end, we finally were able to define, let's say, these, which are all the interfaces that are involved into this process. And once we made the first one, all the others interfaces were really, really easy then to be implemented. Then we have the library, we have the interface. Next slide. We just added the let's say code that basically make the connection among the interface that is expected by the tool, by Akumas, by the platform, and the internal logic of our library. So this kind of things, of course, was really, really easy. Also because, let's say, the protobuf, the gRPC implementation gives a lot of utilities to generate automatically skeleton and stub for accessing the different paths. And once we have finished with this particular kind of view and making all the tests, in the next step, next slide, then we can package everything within a Docker container. From this point on, okay, so the creation of this container, for those that are familiar with Docker, is really, really easy. For those that has never created a Docker container, is not that difficult. There are a lot of tutorials. But once the container has been created, from this point on, let's say Akumas makes its own magic. So everything is working as demonstrated by Martin and Peter just a few minutes ago. Just for the last slide, let's say we have a library that is mainly available as a Python, let's say, library that can accompany, let's say, code. But indeed, the opportunity of having this encapsulated within one or more components gives the possibility to user to exploit this kind of functionality and makes let's say the explainable outcome of the classifier explainable to a large public. At the moment, let's say the initial difficulties were just to get familiarity with the new approach, but again, as I said before, once we completed the first component, the other one were quite straightforward. Thanks.
Okay, thank you very much, Salvo, for this presentation. And we have a third testimonial, which is Uwe. So, Uwe, I give you the floor, please.
Thank you. So my testimonial is coming from a slightly different point of view because I'm also part of AI for You, but recently I started working in AI Plan for You, which is about bringing the AI planning to the European AI on demand platform. So I will just give a short overview of the project and then how we think that the AI for You experiments platform can help us to bring our components to the community in a better way. Next slide, please. So the goal of our project is to create a unified planning framework. We see the idea of making planning technology easier to utilize and to access. And so this so-called UPF has essentially many planners under the same hood, and then exposing them through one unified API. And then using this planning framework internally, it will select the right tool for the job, so to say. And then we have many industrial use cases coming from a lot of different partners across different industrial domains in the project. And for each of those, we want to utilize planning technology to help them do things better. And for this, we have these technology-specific bridges, as you can see on the picture to the right here, which essentially connect to the planning technology. And here, so the project just started very recently, so the discussions are still very initial, but we're probably going to use also the same technology that is used by Akumas and surrounding things like protobuf and gRPC also internally to connect, for example, these planning engines to the unified API, which I think will make it very easy for us to expose our technology to the platform in a component-wise way, but also then to connect them, to connect the UPF to these technology-specific bridges. So just as a very short overview. Yeah, if you could go to the next slide, please. So here are the things that I can see as the added value that we could get via the AI for You experiments platform. I divided it in three categories. I think one is revolving around the UPF usage and extensions, because with this platform, I think we can make it very easy for others to access our technology. If you have seen in many slides before now, this Akumas interface where you can just drag and drop components and connect them. And I think that makes a very nice way to just give access to something without how to say, go to a GitHub repository somewhere and then somehow write your own glue code to your application. I think it could make it easier to create new use cases and to create these technology-specific bridges, for example, in Akumas. I know Martin said earlier that all the boxes in Akumas should be, how to say, application independent, but I think I could see also cases where you just have create a custom box just to connect to the technology that your use case needs. I think it would make it easy to build systems using the UPF and also to extend the UPF as new planners. Since we use the same kind of technology internally, I could also see cases where we basically could recreate the behavior of the UPF within Akumas. Also, we have not really planned or talked about that internally yet. And another interesting point is this integration with the AI for You education. And I think Martin already hinted at something similar because we have talked in about this also in AI for You, this integration between these Jupyter notebooks and components on the platform. The second part is integration with planning adjacent technology, things like plan execution, for example, which we're not directly addressing in AI Plan for You. But if there are generic components for this could be something very easy to just bring together. Mixed initiative planning, which allows essentially humans to plan together with an automated system, or things like goal reasoning to come up with reasonable goals for a planner, and state updates. And there's many other things that I'm potentially forgetting here. And then also, finally, integration with other branches of AI. So can we, for example, easily hook up a learner with a planner, whereas a planner may be used to collect data and then lead to a box which has all of this data in it that we can then hook up to some learning system, and so on and so forth. So these are the things that I could see how we could use the AI for You experience platform first to enrich what we're doing, but then also to connect what we're doing in AI Plan for You in future projects and potentially with other projects going on right now. So next slide, please. And that's it from me. Thank you very much.
Okay, thank you very much, Uwe, and all other testimonials. I think we gave now a quite good overview, and I think we are now ready to take your questions. Are there any questions? No questions at all? Okay. Well, in that case, I think we can close the meeting. We will share the recording, and if you have any questions later on, please feel free to contact me or Work Package 8 leader and ask your questions. I will happy to
Sorry,
answer.
Martin. Can I ask a question?
Yes,
sorry
yes,
for the delay. Just
No
well, maybe it's a side question, but it occurred to me. What is the intellectual property setup for this kind of platform? So if you add something and if you want to have a company or have your own business doing exploitation of these platform with additional tools or without additional tools, how does it work?
Okay, very good question. Very good question. So if you publish a model in the Akumas catalog, it needs to have license information. So that's mandatory. Each model must have a license associated with it. And it can be an open source license, but it also can be a proprietary license. And it can be, it's a structured editor, but it can be freely adopted to the needs of specific companies. So this is definitely allowed to have commercial and proprietary licenses on the platform. And it is also possible to create, let's say, private working groups. So if you don't publish your asset, your tool, you can share it with other users. And by this, you can create mixed teams on Akumas to work together on different tools or on pipelines to make proof of concept and first minimal viable prototypes.
Okay, thank you.
Actually, this also relates to something I wanted to ask. So you can have private components in Akumas. So let's say I create something that I don't think is valuable for anyone else because it just relates to one of the use cases I'm working on, or I just want to try to connect things and to see if it runs. So there is no requirement to absolutely publish everything.
That's correct. So then those are two different steps. The first step is onboarding, which will be only visible privately or shared with other dedicated users. And a second and separate step is then to publish the model into the catalog. And it's not connected and it's not mandatory to publish every model. It's up to the user what the current use case is.
Okay, that's really good to know because I don't think all the things that, especially if you think about these technology-specific bridges, let's say I want to upload one of those and then connect it to our framework, we don't necessarily want to publish this one because it's not really interesting for anyone else because it only provides something to our specific use case.
Yes, so it's perfectly possible.
Okay, thank you.
Any other questions? That doesn't seem to be the case. Then I think we can close the meeting. So thank you very much for joining and see you soon in the next HumanE meeting.
Thank you.
Bye-bye.
Bye-bye.
Thank you, Martin. Thank you.
Bye.
Thank you for the presentations. Bye bye.